Hi, welcome to Working with Raster Data using Python session. This is Nawajish Noman with my colleague Hao Hu from Esri, Redlands, California. Today, we're going to talk about rasters, all about rasters. What can you do with raster in Python, ArcPy modules for raster analysis, the centerpiece raster object. Then we're going to talk about how you can visualize and explore raster data in ArcPy, and then how can you manage your raster data and do some processing. Then we'll move towards raster analysis and then how you can perform custom analysis using NumPy array. So let's get started. When you are working with raster in Python or for any project, what are the things you want to do? You may want to visualize it, and then you want to understand your data, so you want to explore it. You may want to do some kind of data processing, batch processing, or you want to automate your entire workflow. You can also want to do some data management. When you are done with all this thing, you may want to move towards raster analysis. So now, with that, let's see what and how you can do it using the Python ecosystem we have in our system. In ArcGIS, we have a rich Python ecosystem. On one side, you have ArcGIS API that works with ArcGIS Enterprise and ArcGIS Online. In this environment, you actually execute your Python, but the operation happens on a remote server. It's a remote processing. On the other hand, you have ArcPy in Pro, where you run on your script on desktop app like ArcGIS Pro and in ArcPy, and then the processing happen locally on your computer. Now, depending on what you want to do, you can choose your API. We're going to talk about ArcPy in this session. In ArcPy, you have over 1300 functions or tool. Now, these are grouped into different categories like data management, location analytics, cartography, 3D, or even spatial machine learning. However, for this session, we will be focusing on raster analysis and imagery analysis. Now, where do you access these tools and functionality? To do this, you have to look for two different modules. One in IA, another one is SA. Why? All these functionality and tools in ArcPy are actually grouped in different modules, right? And we have these two modules from where you can do all this raster analysis and image processing. Like all modules, it must be imported. Now, how you import make a difference when you are trying to do map algebra expression or operation writing in a map algebraic expression. Now, you can first import ArcPy, and to import your analytical environment, you can do from ArcPy import environment. Then you can import all the tools from SA module by writing from arcpy.sa import star. That's kind of the best practice if you're trying to write a map algebraic expression. Similarly, you can import it from IA module. Now, of course, you can write import arcpy.sa, and then you can use namespace to specify all the tool and function. That is all good. However, you will find out that that's not very convenient if you're writing map algebraic expression with functions and operators. Now let's talk about the raster object. That is the key of everything when it comes to raster in ArcPy. It is the centerpiece. It represents a raster. It could be a single band raster, multi-band raster, multidimensional raster. How do you get this raster object? It could be an output from map algebraic expression, or it could be an object pointing to an existing dataset, or you can create an empty one also using raster info. Output from map algebraic expression or an empty raster is temporary in nature, and you can save it or persist it by calling the save method. It has many properties that describe the dataset. It also has many methods that works with bands, multidimensional variables, dimensions, and slices. It also have read and write methods to convert raster to an NumPy array and to create a raster from NumPy array. Now let's take a closer look at raster object. As I said, you can create it from an existing data set, or it can be an output from a algebraic expression, or it can be created when you create an empty raster. Now if you look at the properties, you'll see that they kind of fall into different category. Like in the first column, you'll see that we have properties, catalog path, name, things like that is temporary. So it tells you about your raster, and then where is it, what it is, what's the name, and then there are more information to tell you whether it's multidimensional, or it has how many bands it has, or whether it's integer or not. Then you know more about your raster, like extent, width, height, cell size, and so on and so forth. Then you talk about the values, what are the maximum value or minimum value, standard deviation, things like that. For multidimensional raster, it has different properties that will give you information about the nature of this multidimensional raster. Then there are other properties that talks about format and pixel type. When it comes to method, also there are different groups. Initially you can see that we have save and export image to persist the data set. Then we have get properties and set properties to get different kind of properties, and raster info. For multidimensional data, we have several methods that works with the variables, and then several methods that works with dimension. We also have methods, as I said earlier, to read from a NumPy array to a raster, or from a raster to write a NumPy array. We'll talk a lot more about it in the next few minutes. Before I move forward, I want to mention something about multidimensional raster. So what is multidimensional raster? A multidimensional raster is a raster which have other dimension like time or depth or altitude. Now you can think of it as a cube, right? One raster which has a cube or a hypercube, all these axes represent different dimension. Now it could have one variable, it could have multi-variable in one file. Each variable is a cube, or it has a cubes, right? A variable has a time or depth or both. And if you think of each of these slices of a multidimensional raster, it represents a 2D array. So if you are familiar with a raster which is a 2D array, now think of a multidimensional raster consists of multiple arrays. A multidimensional raster could be a mosaic dataset or a raster dataset in different format. As I said, that with raster you want to visualize them, right? That is the first thing you want to do, and to do that you can use ArcPy.ia.renderer, that renderer function, to display it. Now if you are not happy with how it looks and you want to change it, you can of course use one of those functions like contrast brightness or pan sharpen or convolution to actually change how it looks. You can also use spatial renderer like vector field renderer to display wind speed or ocean current. It has many properties and methods that we have explained earlier, actually, that will give you more information about the raster data that you are dealing with, and you can explore those values to understand what kind of data you are dealing with. When you are doing any raster project, you will find at one point or the other you have to do some additional pre-processing or post-processing. That could be, getting a subset, clipping the raster, masking some area or resample, all this kind of thing. We have functions to do that. We also have tools in a data management toolbox to do other raster data management. There is a long list of tools on the right hand side that you can see. You can use all of these in ArcPy. When you want to do all this work using multiple raster, you can use ArcPy.list rasters to actually get all the raster and then process them in one shot in a batch processing mode. Now sometimes you may have to do a different kind of data management because some of your raster are in separate files, but they represent different area which you want to bring them together, or different time you want to bring them together. So what you can do, you can use mosaic dataset to do that. It will create a dynamic mosaic or seamless raster for you. It has a table of records and it works like a raster dataset. It lives in a GeoDatabase. To create a mosaic, you have to go through primarily two steps. One, you create a mosaic dataset and then you add raster to it. Here's the signature for doing that work. But sometimes you don't want to create a persistent data set combining all these things. What you want to do, you want to create a raster collection which is kind of dynamic. And how do you do that? You use the raster collection class to do that collection, right? And when you create that collection, you can actually do a lot of things with it. You can have different properties like field and count, but the most important and probably useful things are the filters through which you can actually filter them and do the operation based on the subset that you want. You also have different methods that give you some statistical information like max, mean, median. But the most powerful and interesting one is the map, where you can use map to apply any function or function chain to your entire collection. It also have other methods like mosaic or sort or sum. So as you can see, raster collection is a very powerful way to create a dynamic collection from different raster or a subset of raster and actually work with them. With that, I will hand over to my colleague Hao to show you how you can explore, visualize, and pre-process raster using ArcPy.
Thanks, Norman. In this demo, I will show you how to explore, visualize, and pre-process raster data. We will get a sense of the raster object Norman was speaking about. We'll do the demo in ArcGIS Notebook in Pro, which is a really cool feature released in Pro 2.5. For those of you who are not familiar with Jupyter Notebook, it is a development environment that you can interact with the data, document your workflows, and share your work. So basically, we customize Jupyter Notebook and embed it in ArcGIS Pro so you can perform analysis, immediately review the results in a geographic context. So I'm not going to talk too much about the notebook environment. Most basic thing you need to know is there are two types of cell in your input. Like one is Markdown, where you can put some like narrative text, equations, figures. So another is the code blocks, where you put your Python code. So in this demo, I'm going to show you how to read raster data, visualize raster data, show you some raster object properties, methods, raster data pre-processing, how to save raster data, and how to batch processing raster. Those are things you might want to do before you start analysis. So the first step is to import relevant modules. I need to import ArcPy. I also import all the names that are under ArcPy.sa and ArcPy.ia modules. And by doing this, it will make my code cleaner without calling ArcPy.sa or ArcPy.ia every time. Now I'm setting the environment workspace so that I don't need to specify the full path every time. Here I'm creating a raster object by reading from a raster dataset. I'm reading the elevation data in my workspace. On the left, ELEV is the raster object. We can visualize this raster in Notebook by simply running this object. You can see the grayscale image. Let's put some color in it by using the render method. It is now rendered based on a predefined color map called elevation number 1. Looks much better, right? You might also want to explore the properties of the raster. Let's see, you might want to know the statistics of your raster data, like the mean value, minimum, maximum. And you can do this by directly call the properties of the statistics. And also, if you're interested in the size of your data, like the dimension or number of bands, those kind of information, right? We used to use describe method in ArcPy or like get the raster property method in Geoprocessing tool. So you don't need those anymore. So with the raster object, you can simply get properties like this. It's way easier. Okay. So you can also call the method getRastInfo, which will give you a compiled list of raster information. Let's make it look better. Here, the RasterInfo function returns a RasterInfo object, and we dump it as a JSON string. You can see properties like extend, band count, statistics, etc. So this RasterInfo object can be used as initial properties when creating a new raster. We'll talk more about this in the third demo, okay? Let's try to use raster object to load multidimensional data here. So once we create a raster object based on multidimensional data, first thing you might be interested is what are the information in the data, okay? So there's a property called mdinfo. Similarly, I'm using JSON dumps to just make it formatter a little bit better. Okay, so we will see like the variables, right? Their names, some have descriptions, and all those kind of details. Okay, and if we want to know like dimension information of a particular variable, you can call the method like getDimensionNames. Okay, so in this case, it'll give you like two dimensions, one is standard time, another standard z. Now let's do some data preprocessing. Assume we have an area of interest and we want to clip original elevation data based on it. The function to do this is called clip. One important thing I want to mention is that when calling functions tools under ArcPy.sa or ArcPy.ia modules, we have this basic form of expression. There are two main features. First, functions, parameters, operators are on the right-hand side, while the output is on the left-hand side. Secondly, the output is temporary. So this is different from calling other tools under feature analysis or data management, where the output is on the right-hand side and they are persisted to the disk. So I will emphasize and elaborate more about this when talking about the map algebra in the second demo. Okay. Now we get clip data, and we use resample function to resample it to the cell size we want. Double check the properties to make sure we got it right. Okay. Finally, we call the save method to persist the output. In some cases, you might have a lot of raster data in a folder, and you want to do the same preprocessing before you use them in your analysis. What I'm going to introduce you next is a function called list rasters from the ArcPy module, which can conveniently list all raster dataset in a workspace. So first, let's set our environment workspace to this folder, which has all the rasters I want to list. Okay, so I'm gonna first show you the basic function. Okay, just without any parameters, I can list all the raster data in that folder. And this function can take two parameters. One is called the wildcard, another is called the format. So the wildcard parameter basically allows you to specify like string pattern. So in this case, like I want to list all the raster data start with letter E. Okay, we should just write our function this way. So if you want to just list some specific format of your raster, like grid, you can just do it, specify the format in the format parameter. By doing that, you only show grid format rasters. Okay. So the last step, we want to do some preprocessing. Okay, we're gonna do all this clip, resample, and save in one for loop. And in this for loop, we'll just iterate through all the raster we listed through that list rasters function. And this data will be used in our second demo. Okay. Now I'm gonna hand back over to Norman.
Thank you, Hao. Now let's talk about how you can perform raster analysis using map algebra. Now what is map algebra? Map algebra is a very simple and powerful way of writing algebraic expression using tools, operators, and functions so that you can perform raster analysis. It comprised of input data, operator, tools and functions. It has parameters and outputs. Now output raster is specified on the left hand side of the equal sign, and that is the most distinctive nature of a map algebra expression. The tool and its parameter are on the right hand side. The strength is in creating complex expression. You can write a very complex expression in simple manner when you are using map algebra, writing a map algebra expression. Now tool, operator and functions are available in Spatial Analyst and Image Analyst modules. You can also specify analysis environment using ArcPy.env. Now let's take a look at the map algebra tools and functions that are available. Where are those? They are all in Spatial Analyst and Image Analyst toolbox. So everything you see there, they are also available via SA and IA module in ArcPy. Additional functions are available in ArcPy.ia and ArcPy.sa modules. Now Spatial Analyst and Image Analyst tool functions will require license. So you have to check out license in ArcPy to actually use them. You can also use any other geoprocessing tools. Each tool has its own unique set of parameters. Some are required, some are optional. And this could be numbers, strings, and object or classes. We'll talk about them. Now let's take a close look at the slope geoprocessing tool that is displayed on the right hand side and the ArcPy signature that is on the left hand side. As you can see, all the tool name and the parameters, they are all on the right hand side of the equal sign, where the output is on the left hand side. You can see all the different kind of expression that you can write using required or optional parameter in ArcPy. What are the operators you have for map algebra? There are many operators. So what is operator? Operators are symbols that you can use for mathematical operations like plus, minus, multiplication, things like that. Now there are many operators in both Spatial Analyst and Image Analyst, right? You can actually add to rasters, you can do many other things. However, the important thing is to tell how you tell ArcPy or Python that you are working with raster, not a number or a string. To do that, you have to cast them as a raster using the raster class, right? As you can see in the expression, we have used the raster object to actually specify the dataset that are raster, and then you are adding them with another raster or with a number and things like that. You are also using the output from one expression and adding another raster to it. Now, what is happening when you create an output? The output from map algebra, as I said earlier, is a raster object which is temporary in nature, which means if you don't do anything with it, eventually it will go away. So what you do, if you really want the output to be on your disk, you have to call save and specify a name to save it. Now all output does not have to be saved. You can use them in the intermediate step and eventually it can go away. But the final output, if you want to persist it, you have to call save to save it. Now as I said, the power of the map algebra is from writing complex expression. You can actually combine multiple operator and tool and write a single expression. You can also use the output from one expression and you can use it in the subsequent expression. But the optimization comes when you actually chain local tools like app, sign, cell, which actually operate cell by cell, or some other focal functions all together. And what happens then, instead of running them one by one, it will all run together in one shot. And what you get is an optimized execution, which takes less time to do and very efficient. Now, before we move forward, we want to mention something about classes. We have complex parameter where you have a parameter with multiple parameter, and those things are represented using class in ArcPy. Now it may have a couple of parameters depending on the class. What you can do, you can create a class and then you can query a class and then you can change arguments. So it becomes very flexible and you can do dynamic programming using these classes. And neighborhood as an example of those class. But you can see sometimes to do the vector integration or the raster analysis, you have to use vectors. So input could be a vector or a feature class, and then what you may have to do, you have to combine some vector operation with raster operation to do the work. Example of that would be, here I'm doing from a conversion from raster to polyline and then doing a buffer around it. You can write the vector operation and raster operation all in one expression, and you can actually specify output in such a way that it's managed by the system. So you can see, you can write an algebraic expression, an ArcPy expression to do raster and vector analysis all together. With that, I will hand over to show you how you can do analysis using ArcPy. How?
Thanks, Norman. In this demo, I will show you how to perform raster analysis in Python. I'm going to use a simple story of suitability modeling that identifies the best habitat to set aside for bobcats. So what is a suitability model? A suitability model identifies the best locations to site things such as a new shopping center, a housing development, or a ski area. Or it identifies the best areas to set aside for things such as parks, bobcat habitat, or for flood control. In our simple bobcat example, our goal is to identify the best areas to set aside for bobcat habitat, and we will have 3 criteria. First is slope. So for safety, bobcat might prefer steeper over flatter slopes, right? And from this workflow figure, slope need to be calculated based on the digital elevation data. The second criteria is land use type. They prefer certain land use type, such as forests, more than others, such as commercial or residential. And the third criterion we consider is distance from streams. Locations closer to the stream are more preferred. This is also a derived data, which can be calculated if you have the stream network vector file. Since the slope, land use type, and distance from streams are not in the same scale and unit, it does not make sense to simply add them together. We need to transform the value to a common scale like 1 to 10, so with 10 as the most suitable score and 1 as the least suitable score. And the last step is to weight each of these 3 criteria and add them together to create a suitability map. Now let's dive into the code. Of course, we need to load relevant modules. Let's prepare the criteria of slope. So we read the elevation data. Since the vertical unit of the elevation data is in foot, we want to convert it to meter before calculating the slope. So here I'm using a map algebra expression. As you can see, the input parameters, and the operators, and the functions are on the right-hand side, and output is on the left-hand side. Okay. So I have a factor like 0.3048 applies to the elevation data, and outside that is a slope function, which will generate the slope based on the adjusted dm. And I want to emphasize that the slope variable on the left-hand side is temporary. So if you want to persist the data, you have to call the function save so that the slope will be persisted to your disk. Now get back to the story. The output slope is in degrees. As I mentioned before, we need to remap it into a common scale like 1 to 10 so that it will make sense when combining with other criteria. The tool we're going to use here is called reclassify. It helps us remap a value range to a new value. For example, in the table here, we want low degree slope like 1 to 3 degrees with low suitability score, and high degree slope such for those greater than 25 degrees with a high suitability score. In reclassify 2, to represent this remap table, a complex parameter has to be constructed with multiple arguments. In Python, we have special classes to handle these complex parameters. In this case, we have remap range class to create an object that defines the reclassification of input values. And then we can directly use the object in the reclassify tool. Now let's run it and see how the result looks like. So as you can see, your slope value has been reclassified into 4 values. Okay, so I just covered using classes to handle complex parameters. The next part is quite similar. We remap land use type to new suitability scores. The only difference is that we are doing a value-to-value remap instead of a range value-to-value remap. So the class we can use here is called remap value instead of remap range. Now let's run this part of the code. Okay, as you can see, the land use data has been transformed to a scale between 1 to 10, with 10 representing those higher suitability score area like forest, and 1 represents lower suitability score area like developed regions. Now we need to prepare the criterion distance to streams. We have the stream network feature data. We want to clip it to our study area and use the distance accumulation tool to generate a raster surface representing the distance to the nearest stream. In order to do that, we need the clip analysis tool to clip the stream network first. Now remember in demo 1, I briefly mentioned about the difference between left-hand side output with raster analysis tools functions and right-hand side output with other tools in feature analysis and data management. Here the clip analysis tool is an example of right-hand side output. As you can see, we specify the output shapefile as a parameter on the right-hand side. No left-hand side variable is needed. And when this tool is executed, the output is persisted. So this is not very convenient, right? Especially when you try to chain your analysis together, you have to keep track of the physical location of the output. Luckily, there's a way to resolve this by using a hash symbol, which allows the tool to create a unique path and name for this temporary output. So basically what I'm seeing in this line of the code is that I'm training clip analysis with distance accumulation tool. By using this hash symbol, I no longer need to specify the full path of the output. Instead, the return of this function will be directly plugged into this as an input for the distance accumulation tool. So here, just quickly show you the result of distance accumulation. Okay. Then with a different tool called rescale by function to remap distance value to a continuous scale from 1 to 10. The last step is to assign weights to each criterion and add them together. Another map algebra expression will do the work, and we render the final suitability map like this. The last thing I want to talk about in this demo is analysis environment. As Norman mentioned in the slides, you can control the analysis performed by raster analysis tools with geoprocessing environment by specifying the output coordinate system, cell size, extent, snap raster, etc. So let's specify the output cell size to be 100 and output coordinate system to be Webmacator auxiliary sphere. So after that, we can just rerun what we did before. So previously, I showed you the whole story step by step just for the demo purpose. In your actual coding, you can just combine everything into one complex map algebra expression like this. We can confirm the analysis environment setting has been applied correctly. Okay, let's use this complex expression to do a quick recap. In this demo, we have covered the basics of map algebra, working with operators, tools, functions, complex expressions, complex parameter using class. If you have tools that has right-hand side output, how to change them in a map algebra expression using that hash symbol, and finally the analysis environment. Now I will hand back to Norman.
Thank you, Hao. Now you have seen how you can perform analysis using ArcPy. You have learned about many tools and functions, and we have mentioned that there are many tools available for you to do the work. However, there will be a time when you will come across a situation where out-of-the-box tools, functions, and operator are not enough for you. You may want to write your own analysis or analytical function. This is where NumPy comes into the picture, right? It is useful to write custom functions and custom tool. Now, how does that help with raster? Now, in order to think about it, you have to think, what is a raster? Raster is nothing but a row and column of these cells, which can be think of as a two-dimensional array. So the challenge becomes how I can take a raster and create a numpy array, and once I do the operation, how can I take a numpy array and turn into a raster? To do that, we have two simple functions, raster to numpy array and numpy array to raster. Isn't it obvious? You just have to use this function to go back and forth between numpy array and raster, and you can write your own custom function. As I mentioned earlier, that to make things easier, we also have methods from a raster object to write a numpy array or to read a numpy array to a raster. You can use either one of them to do the job. However, there will be a situation where the raster is so big that you cannot really read one big raster into the memory of your computer, right? In that case, you actually have to read a block of pixel, and this is where the pixel block come into the picture. You can define the area of the raster you are reading using a pixel block, and what you can do, you can process that area and then move to other area. But how do you do that? Now, when you going from one area to another area, what you can do, you can use your pixel block collection to do the job. A pixel block collection, think of it as an iterator going through your pixel block, which define different area in your raster. So you can use pixel block collection and pixel block to actually process large raster. Now, sometimes you don't want to create this numpy array or anything. You just want to directly work with your raster and visit individual cell and do some processing. This is where raster cell iterator come in. You can use this to visit each cell in raster object by using the indices for row and column. It supports iterating over multiple raster dataset and perform analysis at the same location. You can also create multiple raster. Now, you can also access not only a cell that you are operating on, but also the neighboring cell very easily. It is available through Raster Spatial Analyst module. As you can see through the argument that it also have a way to skip the no data so that you can actually operate very efficiently. And it also have padding option for focal operations or when to actually make it easier for going over a large area of raster. With that, I will hand over to show you how you can actually write a custom analytical function using numpy array. Thanks, Hao.
Okay. Thanks, Norman. In this last demo, we will do some custom analysis with raster data. More specifically, we will calculate the steepest downhill neighbor slope using raster iterator, as Norman mentioned in the slides. Firstly, I will quickly show you how the slope is calculated in ArcGIS without getting into too much details. Then I'll give you a brief description of the steepest downhill neighbor slope algorithm. And we will go through the code that uses RCI to calculate the custom slope. And finally, I will show you how to deploy the custom slope algorithm as a script tool in ArcGIS Pro. So this section shows how the percentage slope is calculated in ArcGIS. I'm not going to explain all the variables and equations here, and all you need to know is that it is calculated based on the digital elevation model data. And the rate of change in two directions, horizontal and vertical, are considered. And the final center slope value is calculated based on all the 8 neighbors with certain kind of weighting. Okay? Another important thing you need to know is that this is not the only method to calculate slope. Sometimes users prefer their custom algorithm to do analysis instead of using our out-of-box tools, which also very common. In this example, let's see, we don't want to use slope from ArcGIS. Instead, we have a new algorithm called steepest downhill neighbor slope. The idea is to pick the steepest of the 8 adjacent point slope values with the constraints that the point must be lower in the elevation than the center point. So here is an example. We have the DM data on the left. The number here represents the elevation value. Say we want to calculate the steepest downhill slope for the center cell. First, we need to calculate slope by comparing to all its 8 neighbors. We don't want to consider the neighboring cell which has a higher value than the center cell, we just simply mark it as NA. So that ends up with we're choosing this green cell with value 6, the steepest downhill slope. We will assign value 6 to our output. In this algorithm, the slope value is only determined by one neighboring cell, although it has to consider all the neighbors. In terms of the usage, most drainage basin algorithms use a variant of this slope, looking only for the neighbor into which water will flow. So here I have the code snippet implementing the custom slope using RCI. First, we load the relevant modules, read the input DM data, get its cell size information because we will use it to calculate slope later. We also need the rastinf4 to create an empty output slope raster object. Before creating the slope raster, I have an additional step to set the pixel type. This is because our DM raster is an integer raster, and we like the output slope data to be a floating point raster. Next is to construct the raster iterator object. We have both input DM and output slope for the raster's parameter. We iterate through the DM, and for each cell, we loop through its 8 neighbors using relative indices. We only look for downhill slope. After calculating the slope for all the neighboring cells, we pick the steepest one from the slope first. And if this list is empty, it simply means that all the neighboring values are greater than the center cell. Okay? If that is the case, we don't do anything, and the value will be handled as no data. Lastly, we save the output. Now let's run the code and see the final output. Okay, so you may stop here if you only want to deal with Python code, but sometimes users may want to use the custom analysis as other geoprocessing tools in the toolbox. By doing that, it becomes easier to use as part of the workflow, like in Model Builder, where you can just chain system tools and your custom tools together to perform your analysis. In order to do that, you will need to deploy your code as a script tool. I'm going to show you how to do that. So first, you need to create your own toolbox. In the toolbox, you can add a new script. So here I already prepared the script. Let's add it to see what's in there. It's pretty much similar to the code snippet I have in the notebook. There are two differences. First, as you can see, my input DM and auto slope are defined as parameters because I don't want to hard-code them, right? And the second thing is that I have added this ArcPy add message thing, just try to report the status of the program. Now, I can simply open the model. Once I specify the DM, input DM, and output location for the slope, I should be ready to run. Okay, so in this demo, we went through using RCI to calculate a custom slope algorithm and deploy it as a script tool. Now I will hand back to Norman.
As you have seen, we have talked about how you can visualize, explore, manage, analyze, and share raster data using ArcPy. Now we have not covered the sharing part of it. It is covered in other sessions. You can actually look at those videos. All this work that you do with raster, these things are available in ArcPy IA and SA module. You work with those two modules to do your work. Raster object is the centerpiece which represent a raster. It provides many useful properties and methods for single band, multi-band, and multidimensional raster. Map algebra is a powerful way to perform raster analysis using tool, functions, and operators. You can combine raster and vector tools together in an expression to perform analysis, whether it is a vector analysis or raster analysis or a combined analysis. The output from raster object is temporary by default, and if you don't persist it or save it, eventually it will be deleted by this application. If you want the final output, you must save it. You can also extend the analytical capability by writing a custom code using NumPy and raster cell iterator, etc. Before we say goodbye, please provide your feedback for this session by clicking on the session survey link directly below the video so that we can take into account your feedback and improve the session for future. Thank you for listening this session. Hi, thank you for watching the session. This is Noman here.
Hi, this is Sharmishta. So let's see, we have got a lot of interesting questions. So Noman, how would you say, what is the difference between ArcPy and ArcGIS API for Python?
Okay, so due to the time, I'll try to answer all of them very briefly. In simply, you want to use ArcPy when you are actually doing the processing locally using your desktop. And ArcGIS Python API you use to actually execute your operation on a server. Now, of course, ArcPy also have few functionality that you can execute on server, but the primary distinction is ArcPy for local desktop, ArcGIS Python API for enterprise operation.
Cool. With all the demos that you have shown, are these notebooks available somewhere, the notebooks and the code example?
It will be available to you along with the presentation, but if you don't find them, just shoot us an email and we'll make it available to you.
All right. We saw that you work with both SA and IA module. So Jason is asking, why do I need to import arcpy.sa or IA since the first line is import arcpy? Does arcpy include all arcpy modules?
That's a great question, Jason. Thanks for asking. So conceptually, you might think that the ArcPy should load everything, but that's not how Python work. And you can imagine it the way the extension work, right? We have when you buy Pro, you have certain tools that with extension, you get additional thing. Similar thing with the ArcPy. And when you actually want to load it or import it, you don't want to import everything and consume all your memory and resources. So as you have the functionality and as you use it, you can actually load them as needed.
Why do I have to save the raster output in Python after creating it?
That's a great question. The reason is very simple. The Python, if you remember the poll that we have asked, the Python is used for different kind of thing, automated workflow, modeling, advanced analysis, and stuff like that. And when you do this kind of workflow, not all output has to be persisted. You may just want the final output. So what happened to the intermediate outputs? If you have to clean this all up, that's actually a much more hassle for you. So what we did, we actually take care of them and clean this up for you so that you can focus on the final output that you need and you can save them.
Do I need to import both the modules from ArcPy, and can I use IA and SA modules for raster data management? What do you think?
So IA and SA, Image Analyst and Spatial Analyst, primarily focus on raster analysis. For data management, we have the data management toolbox, and you can actually import the data management tool from that toolbox and actually run them. So for data management, use the data management toolbox, DM toolbox, and then for raster analysis, use either SA or IA depending on your workflow.
Okay. And can we combine vector and raster analysis tools in an expression? Is it efficient to do that?
The short answer is yes. The long answer is depends on what you are doing and whether it is efficient or not. Now, for example, if you are putting a buffer inside some other operation because you need a polygon and then you are using it in say, zonal statistics, there is no problem doing that. That's pretty efficient.
And you may not have to do that because actually zonal stat takes feature already as input. But if you want to do the buffer and then use it, that's good. However, if you are using the local operation, some of the operations that are highly optimized, now putting a feature or vector analysis within that may not be efficient. So you have to be, kind of choosy about when you are actually mixing them or not mixing them together. The good part about mixing them that the output is actually managed by the system. So you don't have to specify the output. You can use a pound sign and then it will be managed by the system.
Cool. We have a question from Azin. Norman, we know that you are the hydrology expert, so we got a question here about, hi, can we use NumPy to generate hydrology rasters like flow direction? So what do you think about
Oh,
that?
Ajin, thanks for asking that question. And I'm sure it's absolutely coincidence that somebody thought I'm gonna be a hydro guy here. So the short answer is don't try to do that. You can do that, but what you will be doing is you will be recreating or recalculate the everything from scratch. So the way the tool works, you have to actually do this full computation, this global analysis to really do your computation. For flow direction, it's local. Of course, you can do that easily. For flow accumulation, it's actually global. So it may not be very efficient because we have actually done a lot of work to parallelize this work and do something with it, right? So yeah, of course you can write it from scratch, but not a good idea.
All right. When should I use a raster cell iterator?
Not for doing flow direction, right? The answer is when there is a tool available, don't try to use it. Use it when you don't have a tool available or you cannot combine the tool together to solve the problem, which means when you are using raster cell iterator, you are writing it from scratch. However, there are a couple of cases where you might find it really efficient. For example, you want to read some random data or you want to modify some of the random cell value, not necessarily random. So you know a location and you directly access that cell, get that value or replace that value. Those kind of thing, raster cell iterator is your lifesaver. And when you are writing custom operation, it's a great thing to use.
Cool. What kind of efficiency gain can you expect by using the chained or stringed functions instead of individual statement or functions? How might this impact maximum memory usage when processing either very large single dataset or many tens to hundreds of thousands of small rasters?
It's really a great question. But the answer is twofold. Now, chaining can be interpreted in two different ways. So let's say I have three operations and I want to do A times B times C divided by D, things like that. Now, when I write it in one expression, it is highly optimized because everything happens in one shot. And then when you save, it gets created. Okay, the IO is very optimized, operation is optimized. I can also get similar kind of optimization if I just did A plus B, took the output, did not save it, did not do anything, and then multiply C divided by D, and then two-step, and then finally save D. I will get the same operation advantage. The tricky part here is not to persist the data. And if you don't do that, you can get extreme performance because there is no IO. These operations are fast and it will happen in one shot. So I hope that answered your question. Okay.
Cool. So there is another question about parallel processing. This one, shall I execute all raster analysis tools in Python to take advantage of parallel processing?
No, and it's a big capital N capital O. The reason is very simple. because the multiple processor that we have shown here are for the tool that are not already parallelized. We actually have parallelized a lot of tools. So when you are running it from UI, it's already parallelized. When you are calling it from ArcPy Python, still parallelized. You don't have to write your own code. The examples that we have shown you, when you have to write your own parallel processing, and only then you can do your own code. Otherwise, it will happen from everywhere.
Cool. Is there documentation on when to use IA versus SA? Is the image analysis module eventually going to be a complete replacement of the Spatial Analyst module? If not, why are there many of the same tools in both modules?
That's a great question. The answer is, first answer, is there documentation on when to use IA versus SA? The when, the answer of the when depends on what you are doing. The way I try to explain it, that you might be a plumber, you might be an auto mechanic. Both of them need screwdriver and few things. So there are some common tools, but the workflow are completely different, and they may have some extra tool to do their job. So the common tool does not define the extension. The extension is defined by what is not common. And you will actually see, depending on the type of operation you do, you actually have to use Spatial Analyst. The other one, you have to use Image Analyst, which is more geared towards image processing, whereas the Spatial Analyst is geared towards spatial analysis with raster data. No, there is no plan to that one will supersede the other. There is a place for both of extension, and it will continue to remain that way.
That's very helpful. Numan, does the utility structure or the syntax of the tool changes when working with the Mosaic dataset?
The tool signature does not change. The how you specify the input may have to be slightly adjusted depending on what you are using, right?
Okay. Can I use IA for creating geoprocessing task on ArcGIS server?
IASA both can be used inside a geoprocessing service which you publish and can be tasked on a server. That is true for all geoprocessing tools.
How can I watch this text session after today, after the live session is over?
I think it will be available as recorded and you can go and watch.
All right,
There
that's
is
pretty much.
there is probably another question that we can answer. I see another question coming up that ArcPy module provides similar thing.
Sure, yeah.
That one, yeah. So the short answer to that, yes, we have a lot of projection and translation, lot of image processing, raster processing capability. They are just scattered in different module, and primarily these are in data management module, and image processing by also have lots of capability. So please check it out, because we handle and manage raster data pretty well.
Cool. Do you have anything more to add? We have another 2 minutes. There are no more questions yet.
We can answer the question, who do we email? Well, everybody knows it's very simple. N Noman, N is the first initial, NOM plus. Just don't spam me with all the emails. If you are watching the session and want to get the notebook, just email me, nnoman@esri.com. Okay. And there is another question I see about the sharing the tool. The question was, what session covers the sharing of the tool? I'm not quite sure whether you are talking about publishing the tool as a service, or sharing is that, or creating a new tool. But there are enterprise sessions that will cover that, or we have Python session that talks about it. If you can find anything, again, reach out to us. I will point you to the right resources.
Thank you so much.
And somebody said, best session I have seen in all day, whoever that person is. Thank you very much. It's been a pleasure to present our material to you. And thank you for watching.
Thank you for joining us. Thank you, Noman, for answering all the questions.
Thank you,
That was a lot of
Sharmishta.
questions.